Okay, Assalamualaikum and good morning. On step response, here is topic 8. This is not topic 5. Topic number 8. An RC and RL circuit. Okay, this is the flow of this chapter. Firstly, we'll take a look on natural response of RL and RC circuit. So firstly, we need to understand what is natural response. Okay, it refers to the behavior of the circuit in terms of voltage and current when there is no external source. Okay? So how voltage and currents behave in the circuit, where the circuit only have R and C element. Okay, no source. Okay, maybe the source is disconnected. Maybe the source is here, but the circuit is open. Okay, source. Okay, and the term first order circuit is referring to RL or RC circuit because of their voltage and currents are described by first order differential equation. What is first order differential equation?
Okay, on the left side is the first order circuit. Okay, this one is first order circuit. First order. Okay. You can see from the equation there is a first order differential equation. Okay. Uh, on RC or on RL circuit is first order differential equation. Okay. On the right side, which is RLC, we see this one is second order. Okay. Second order differential equation. You can see that this equation, there one term in this equation was differentiate two times. Okay, it's from L di over dt. Okay, we differentiate this equation in order to make only differential equation. Okay, for easy calculation. So in order to eliminate this integral, to eliminate this one. Okay, so we get finally only differential equation. We don't want to mix differential and integral equation. So that's the reason. This is first order. Okay, when we only have RC and RL, when we have all the three RLC, okay, it will be second order. Second order differential equation.
Okay, let's consider this natural response of RC circuit. Okay, let's consider this circuit. Okay, as I mentioned earlier, we have RC here connected in parallel, and it has also a switch here, and we have a power source here. Okay, so in this case, we use a DC power source. At t equals 0, the switch is open. Okay, consider the following conditions. The first one, so maybe it's better we use timeline. Okay, so 0 is here. This is before 0 and after 0. At time before 0, switch is in closed position for a long time. Meaning that the circuit is completed, is energized. Okay, it's energized like this. Okay, and at t equals 0, the instant when the switch is open. So at 0, the switch is open. Okay, meaning that no more charge will be provided from the power supply to the circuit. Okay, no more current. At T after 0, switch is not closed for a long time. So the switch remain open. Close, this is the timing where the switch is open. Okay, then after that, it's not closed for a long time. Okay, so what happened in the circuit is that this capacitor C will be charged. Okay, okay, when the at T minus at T before 0. Okay, and after it's open, so the charge will be discharged. No more connection here. So the charge will be discharged only in this circuit. Okay, R and C. Okay, this is what we call natural response. Okay, let's go back to the definition. The behavior of voltage and current of circuit with no external source. Okay, with no external source. Okay, let's take a look. What happened to the voltage and current of this RC national response circuit for T and equals to 0 before 0. Okay, remember the switch is connected and at 0 is open. Okay, let's consider the initial voltage is V naught. Okay, this is the initial voltage. V3 equals to V naught. So after 0, how the voltage equation will change. After 0, there's no more voltage source. So we only consider current at the capacitor and the resistor. Okay, it must be equals to 0 with different polarity. So IC plus IR equals to 0. Okay, so to determine current for the capacitor, we use the following equation: C dV over dt. Okay, okay, where does it come? As you know, current is dq d over dt. Okay, so q equals to cv. So we just change into this equation, we will get this equation. Okay, so q get inside, c is constant, so get out, and v is the function of t, so we get this equation, and vt over r is Ohm's equation. Okay, so it must be equals to r. So we move around the equation, c to the right side, and finally we get this equation, and this is the last one. Okay, so we have is dv t over vt equals to minus 1 over rc dt. So what we want is vt. So we need to integrate this equation. Okay, we need to integrate this equation. Integration on v. Okay. From here, we integrate both equation. Okay, we can integrate from on the left side is from v naught to Vt, V0 to Vt, integrate from V0 to Vt. Okay, so we get ln Vt minus ln V0. Okay, on the right side we integrate. On the left side, integrate from V0 to Vt. On the right side, from 0 to t. Okay, this is integration on V. This integration is on t. So what we get on the right side is minus 1 over c, t minus 0. So it's minus 1 over rc t. Okay, finally we get this equation. So from here, we know ln is the base is e. So we don't want this one. We move it to this side. We'll get Vt equals to V0 exponential minus t over Rc. So this is the voltage. Okay, the voltage after 0. Okay, before 0 is V0. After 0 is V0 exponential minus t over c.
Current, just divide R over T and we get the current for T after 0. Okay. Similarly, for the energy, the stored energy in the capacitor, just use the equation, replace Tg square like this one. Okay, so we get 1 over 2 T V0 square exponential minus 2 T over RT. Okay, as this is a natural response, so it doesn't have external circuit. So the voltage, initial voltage at the capacitor will be released into the RC circuit. So you can see here the voltage from the circuit will decay until it reaches 0, where the C is fully depleted or fully discharged. So in this case, time constant for RC circuit is tau. Okay, is this part. Okay, is tau equals to RC. In this graph, you can see if we change the RC or the tau, we can see the change in the rate of voltage depletion or the voltage rate of the decrement. Okay, decrement of the voltage. If we increase the tau, it will be slower. Okay, this one tau equals to 2 seconds, R times C equals to 2 seconds. And if we make it small, then it will be discharged faster compared to tau equals to 2 seconds.